G'day viewers all. Look at this, the next day and the device arrived. Hangzhou Ruifeng Technologies Co Limited. This model is 1000 watt 20 amp, 50 volt 20 amp. USB and the Bluetooth interface on this model, so this transformer is going to go on that. Let's get it all set up. I can't wait to set this up. It's got filter caps, but I think they are high end, so to speak, high temperature. ECD 470 microfarad 63 volt. The actual bit that does the hard work is under this heatsink. We'll see how we go. Just monitor that. If I load this thing up, we'll see how we go. The grease has got to wear it on that fan. Bit stiff, but it's getting easier to turn. I will do a hack on that heatsink if I work this thing too hard. We'll monitor that, but yeah. Yeah, if it's going to be 1000 watt as it says, I think that heatsink's going to have to be a little bit bigger with a bigger fan. Now I've got a bridge rectifier in there. I've got a, let's see. I've got to find my cap stash. Because I know I've got some bigger sort of capacitors that are rated for 63 volts or higher. I could use for that to filter it. So let's build this thing. I can't wait. I'm excited. Bit of geek porn, as I say. As some people say, gives you a tech hard on. Let's get me a little rectifier out of here. That one there is probably overkill. 1000 volt 50 amp. Yeah, that'll be overkill. I've got smaller ones, just got to find them. Then again, I'm probably going to need it because TV power supply boards have got a big rectifier on them, but you're only rated at 6 amps anyway. So that's transformer's probably going to overload that rectifier. I probably will need to use this one actually. Full bridge rectifier. Here we go, positive, negative. AC, these two are AC. Probably need a heatsink for it later on, but we'll see how we go. 1 kV 50 amp bridge rectifier, and get a capacitor to come off that to go between that and here. Your inputs. So yeah, this is really nice. Yeah, these are the ones that Dave Jones had in EEV blog. This is the next bigger one than the one that he showed of his biggest one. Bigger, the one up from that. It's a model DPS 5020, but it's 50 volts out. The transformer you can have 60 volts, up to 60 volts on the input, but you don't expect it to step up the voltage. It won't. You're just going to step it down on the output. I've got to find. Anyway, let's get this thing built. Let me just build this thing up first, then we can talk later, eh? I'm just so excited here. No load test. I got 35.98 volts, so set it at 36 volts. I got no load on that. And current's maxed out, set to 20 amp. Look at that, 35.98 volts. Going in. Yep, not that badly off. 36.4. It's actually quite good. Now I've got to get a box or something to put all this in. Whatever shall I use? I think I'll plug the Bluetooth thing in it later on and we can test it on. I'll put an input on this thing. Power it off. That's off now. So I'll power it on. I've got to set this function here. Read the manual, as I say. Enter. 10 amp, okay. Set that. I have a voltage protection. I can set that later on. Nice and bright. Which is a really cool motherboard BIOS font. I've got to read the manual how to use all these things, but it's on constant voltage mode. That is very good. What can I pop on this thing? Press it off. Actually, hey, ZVS. This will run the ZVS now. I got a good ZVS driver power supply. Yeah! And there's something DC motor. I got a DC motor somewhere, but it's a big one. Maybe get this scooter off the ground and I can power that scooter up. Just hook that motor, 24 volt motor up, and let's see how that motor goes. Let's see if we can make that thing run faster. Let's see how it goes. That'll be an ultimate load test. It's a 24 volt high powered DC motor. Give it a test. Alright, I'm excited here. 10 volts. Not even bloody warm. That's at 36 volts, but the motor's pulling it down to 33 volts. 30 watts, no load. Oh, 10 amps, that almost started up. Not even bloody warm. Oh, 10.07 amp, the fan came on, and I dropped the load down and the fan turns off. Oh, this is porn. Now I'm going to press the volt button, then turn it back down. I set it to 10 amp what I set to. Oh, look at that. That's porn. Yeah, let's set the current more, eh? I can change the steps. 15 amp. Power on. 40 volts, set. Not even breaking a sweat. This thing's fucking porn. I can't get over it, believe it. Fan comes on, turns off. Oh, that's good. 30 watts. I'd rather get a big ass battery and power this thing up on here. Hey, hey! One's down. Yeah, the rectum fire's not firing any rectums yet. Huh. Staying cold. Alright, well, that works good. I'm going to play a moment to get my phone and see what the Bluetooth feature does now. I'll just power this off for a minute and go get the Bluetooth function, see how that all works. I really want to get an enclosure for this thing now. Oh, I can't wait to have it all set up and finished. It's got short circuit protection too, so this thing's awesome. I won't even buy another one of these things yet. This thing's awesome. Anyway, alright. Let's go get my phone and get the Bluetooth thing plugged in here. So we'll power the whole thing down from here. Yeah, this is just temporary. I'm going to have a probably an IC cord and a main switch for this transformer. And just a little heatsink on the rectifier. That actually got hot. This, say, it's not even warm. This took all the brunt. That's a very well laid out circuit. That's awesome. It's just, yeah. If you want tech excrement from China, that's actually not that much of tech excrement. Get this. I think I'm going to order another one. I'm thinking about ordering another one before July 1 when the price goes up. Yeah, alright, let's get my Bluetooth thing set up. I couldn't connect to it on the Bluetooth. I've got to read the manual, see how the Bluetooth part of it works. Might have as an app or something you can communicate it to it with. But also cover the USB interface as well. So, well, I'd like to use this, but unfortunately it's TFG, too far gone. I couldn't fix it up. I'll have to keep my eyes peeled, I think. Maybe one of my emails, a digital one of these. I gotta look at my storage and I gotta get a digital one, stuffed. Because the digital ones are crap anyway, but the enclosure's the same as this one. I'll just use a digital, take the digital part of, I'll say in digital because I'm not going to do it to an analog one, relax, I'm not going to do it to an analog one. But a digital email meter I've got in my stash, like one of these ones. Oh shit, lucky didn't do any damage. It's one of these but with digital internals. I think I did a video on them ages ago. They're Q4As, they're not very good. I just got them mainly for the parts, but the enclosures are the same as this. I'll just use one of these and put the guts in one of these. I'm thinking about it, but it look kind of cool. I can hang it, but it won't look good laying on the top of a bench. But I'll try it anyway. Just put the transformer should fit in there and the power supply should fit in there and have some little vents for the fans. And see if there's room for the fan, for the interface. I'm not sure yet. I might try, think of something else I could use as a box for it. It definitely needs an enclosure. I don't want a wool on this. That'd be nice, but I don't want a wool on that. That's a timer device. Well, there was nothing much in there anyway. I could put it inside here. Put the display here. A transformer on the internals, and they have a display here and output here. But I don't want to ruin that. I'll just see if I can find something else similar to something like that that's a little bit smaller. Yeah. Anyway, I'll see what I can do on my travels. I'll keep my eyes peeled now for a good enclosure. That thing's awesome. Yeah, put all that all in the one enclosure. Bolt the transformer down. Have all that in the enclosure together. With a transformer in there and this. This is absolutely ideal. I told you it was going to be a good project. Awesome. This is really awesome. I just love it. I'll just give you a quick look over the instructions. That was a nice little test. That's plenty of bloody current there. It pulled close to the rated 10 amps that transformer. It's supplied at least up to 10 amps or a bit more, so that's not bad. It didn't dull this down too much either because there's still enough current to power this without it shutting down or dimming its lights, so to speak. This still had enough power to run that and be fully loaded at 10 amps I set it to, so that's pretty darn good. That's actually more than what I needed, which is perfect. Tells you how to use it, so not too hard to use, but it does the important features of setting the limits so I can power sensitive equipment and not blow it up, so it's good for that. You can do all sorts of things to set how it boots or set. You can just turn this and set it so that just acts as a variac no matter what setting it's in. So you can change all that sort of stuff. So you've got to read all how to program it all, which is unprogrammed. I was just using it on stock mode. But see what I mean by it uses motherboard BIOS font. That's motherboard BIOS font, I call that. It's the same font lettering the motherboards using their BIOSes on earlier motherboards before UEFI era. Now I've got to do some studying on this. It's pretty damn easy to use. Brightness, overpower, So you can't go over a certain wattage or set the current, you can't go over that current or you can't go over that voltage. It's just set the currents and the voltages and the wattages depending on what your circuit is. So I'm going to put the collection of another integration and digital control functions in one. It's adjustable output voltage ranges 0 to 50 volts, step by 0.01 volts. 0 to 50 volts if I have this as a 50 volt going in there, but it's not. So this is not a 50 volt transformer, because if I use these other two taps, it's 52 volts AC, but after that it'd be a bit too high, just over 60 volts. Because this is only 32 volts AC here I measured, but it's actually 40 volts unloaded going into there. And if I did use this higher voltage tap, I get the higher voltage, but I think I'd have the lower current. 0 to 56 volts at 2 amp, and this is just well, I think I'm pretty sure it's how it's set up. I might have to recheck. I think it might be 1 amp on half a tap. That makes more sense. Yeah, I only use one of the taps, so it's probably 1 amp actually. Which, well, I did the short circuit test. It provided plenty of power, and this wasn't even phasing. It didn't phase it. Like, it didn't cut out altogether because this was so overloaded, but it's fine. This needs a heatsink just for long-term use, but that took all the brunt. This wasn't even getting warm. The fan came on as it should, as I was loading it up, but this actually takes the heavy weight. I might just do some low voltage tests. And just, I need a scope actually. I can't just put it on a speaker and just slightly turn it up at a certain level and watch the cone move in and out. Because I could turn it up and watch the cone go one way or the other and listen, and if there's any ripple. But that's not a very good way to do it. I need a scope on the output to see how clean the signal is. But 100 microfarad is actually should be plenty to pre-clean the signal, so these capacitors can finish off the job and make it a nice good DC, because all the regulations are all done on here. But I'm really happy with this device. Okay, you must make sure that the input voltage is 1.1 times higher than output voltage. Under large current circumstances, pay attention to heat elimination. DC 6 to 60 volts input. I might just try and swap the taps over, just see how it goes. And disconnect this and measure it with a multimeter, see how it works, how the voltage is there. But I'm pretty sure it's going to be pretty high. 1.1 times higher than output voltage. I might try it to see if it, yeah, get the high voltage, see how it goes, and measure it, see what the voltage is like on its full 56 volts rectified. But I'm pretty sure after I rectify that, it's going to be a bit higher. But anyway, so the experimentation we'll do afterwards. Anyway, that'll be enough for now. Thanks for watching.